Thank you. Thank you. Yeah, I think if you've been to the talk by Romeo this morning on social theory and symbols of power, I think having your own bottle of water is very much a power signal, and I feel a bit out of place there in that sense. Like my hexis is not very well at the moment. I feel like. We are all in this together, right? We all share these same experiences, and like, who am I to tell you about legacy and how to deal with that? After all, I think many people have been trying to do the same thing as well, from expertise and experience. So, in this case, today's talk is just a number of things that I found useful and that I hope will be useful to you too. It does sound very violent, all of this brutal stuff and table flips indeed. In that sense, I prefer having this nice little table flip there on the screen, because as you know, working with legacy code is, it sometimes invokes aggression. And I'm working on a legacy project now for about 2 years, mainly from home. And this is even more of a difficult situation, where, like, with colleagues in the same office, you can at least share your feelings there. But sitting in my attic at home, it's a different story. So at least we have Slack, where we can post these nice little snippets from the code base, sharing the ugliness there, right? And we have a lot of fun with that. But if you look at the kind of emotion that is going on there, like it's aggression, you're angry, you're mad at whoever wrote this crappy code, right? But as is often the case, if you look behind the anger, there is really sadness, right? Because you would have wanted those people to have known more about the project, more about the domain, more about the constraints, or they should have been warned about their wrong assumptions, right? So it's really sadness that not everything was as good as it is today, maybe. And yeah, there is always the technical debt, like carrying it. It's almost like this, like it's. I mean, this is not carrying the earth, right? It is, Atlas is carrying the heavens. It's like the heavens of technical debt are pushing down on you, and you have to prevent it from crushing all of the productive people on Earth, right? And this can feel like a lot of weight. In this sense, it's also technical debt weight, and you feel it on your shoulders sometimes. And another mythical image I was reminded of was Sisyphus, who is pushing up, by means of punishment, this boulder up the hill. And he never reaches the top, so it always keeps rolling back just by definition, and he has to keep pushing and pushing, and basically until the end of times. And this is called continuous improvement, right? So we give it a nice name, but yeah, we all know that we will keep falling back, and the ball will keep rolling back. There's always some part of the project that you open up, like a folder or a file, and, well, you stare at the ugliness in the face. I find it very useful to use a knowledge or a rationality. I don't know, in this area of complexity and strange things. I want to know, what can I know, right? So I want to have my mind there and be safe of at least some things. Turns out, if you're working with legacy code, there is not much you can know just by looking at the code. It's really hard to figure out what's going on. But there will also be old stuff used, old languages maybe, or old language versions, old libraries and frameworks that you no longer understand. And part of them being old is that maybe sometimes documentation isn't even available or isn't that good. Also, blog posts don't talk about those versions anymore because it's not cool anymore. So you're a bit in the dark there. And trying to figure out what is the meaning of all of it, that's sometimes a big challenge as well. Like all of the domain knowledge has left the building, like if you're really unlucky, right? because usually there will be someone in the office who is still a domain expert and that you can talk to. But at least trying to read the code is really hard. And I think this is actually pretty good code because this sort of reads like a sentence. So I'm sure you can figure it out and even talking to someone. But usually code, like legacy code, is just manipulations of little bits of data and shuffling them around, and forming basically just mutations of state, but without any meaning or intent, right? So that's the difficulty there of legacy code. And I think intent is a big issue, where even if you know how the code works, if you can figure it out, if the code isn't that bad, you still don't know why people have written it like that. So they must have had some reasoning process going on, or like we expect developers to be rational people, right? So there must have been some reasoning going on, like behind how did they make these implementation decisions, but nobody knows about the reasoning anymore because they also didn't document that part of the work. So what you can see is the outcome, but not every decision that was made along the way. And this is where I think that there is a big issue with the whole saying that code should be self-documenting. We all repeat this slogan to each other, right? Because we don't want all those comments. But in a couple of years, if you look back, well, you would be very happy if the original author would have added some comments after all. But what in fact happens is that we are misunderstanding it. In the first sense, we are supposed to be introducing not comments, but for example, better variable names or better method names to say what we are doing. But in this sense of explaining why we are doing it this way, or why somebody should not try to refactor this, right? That's also one of the reasons for adding comments. In those cases, we need those comments. So I always try to ease myself into adding more comments. I think that's suggestion number one for not just dealing with legacy code, but also for writing code today, which will become the legacy code, right? Somebody will inherit this code, and they want to know what your thinking was. And I still feel it's really hard to do this because we, or at least I, have learned not to write any comments in the code because it feels like you're maybe humanizing the code. You want it to be almost like machine written, very clean, very structured, and there should not be a sign of an internal dialogue that's going on, or like even fear or doubt. That's the kind of thing I'm adding in my code today, and also reviewing legacy code. I'm adding these comments saying, I'm not sure if this is the best thing, so that the next time somebody reads this code, they will know about my doubt, and they can always, if they know more about the problem, choose a different solution. But otherwise, it's just like it's written in stone. If there's no comment, it's like this is the final answer. You don't need to think about this ever again. As an example, I was looking at this bit of code. If invoice lines have different VAT rates, like VAT is added on top of the amounts on the invoice, right? Then you have to calculate the net amount on the lines times the VAT rate for the line, or else you would take the VAT amount for the total invoice. And what's the reason for this? It was not documented, is that there is rounding in between. So if you calculate VAT on the lines and then make a sum, there are rounding errors there. Or not errors, but it's expected to be like that. But this is the kind of thing where I'm trying to refactor this code, and I'm like, yeah, why would you do that? Why don't you just always sum the lines? And it turns out there are sometimes sense of differences there. So I would add a comment there explaining why this is, so that nobody ever tries to touch that logic, right? I think the piece of code that explains this or that contains this knowledge about VAT calculation is an example of if the previous developer, or if the developer who has written that original code would be still around, they would have this knowledge, right? They wouldn't have to think about it. They know this, and they are certain that it's true. So this brings us to, like, if somebody new comes in and they look at this code and they try to understand what's going on and maybe change it, they are the original owner is no longer around. So this knowledge, the reason behind the code is also gone. So you could say that legacy code is basically code without an owner. As soon as the original owner is gone, the code is lost, basically. Even if it has tests, right? Because we still don't know what's going on, why the code is like that. So not much to know. Still, yeah, you should try to increase the knowledge about the code and by adding comments while you're writing it. So instead of asking ourselves, what can we know, we could also wonder, what should we do, given this ball of legacy code? And surprisingly, maybe a good advice could be to read books. And well, I think this is quite an underestimated solution. There are some very interesting books on the subject, some of which I can recommend here. As you know, there's Michael Feathers working effectively with legacy code. I think it will be useful for everybody to read this book. Then there's Adam Thornhill, who has written, I think, 2 books on analyzing your code combined with the history of your code. So that to me was a very interesting idea. Like, you have the history of your project, if you're lucky, I think, because sometimes there is this very big initial commit and you don't know what happened before. But usually there is some history in the code, and Adam explains how you can use that knowledge to figure out issues with the code. So it's like the X-rays. He proposes, like, look through your code. What's going on? Where is the change happening? Where is the difficulty? Which things are too much coupled or too large? And not only make an analysis right now, but keep track of the data or the metrics over time, which is a very useful idea. And then the Mikado method is a very useful book if you have a large task in terms of rewrite, or maybe you want to switch frameworks or something like that. Then the Mikado method can help you well, set course, but also make sure that along the way you will have working software. And you won't have to make a big bang release of something developed completely separately from the original software. So very much recommended. Yeah, I mean, just take a look at your own. I can't tell you all about these books, but it's also the annoying thing about conferences where you go home and you have this whole list of books to read. So I hope I'm I'm not piling up on top of that. So usually we are so very scared of legacy code that yeah, we see it all as darkness, and we don't even dare to look up from like we look at the light spots, and we don't even dare to look into the darkness or look up. That's where I think the big idea behind Feather's approach is to make things testable. Like testing is a way of shining light on things, and I think you already know this advice when it comes to legacy. You take the mess, you make it testable by creating a sort of a test harness, and then you start testing. So you can at least describe the behavior that this object is supposed to have, and then you can start refactoring the insides, because once you have tests, yeah, that's when you can start refactoring, or at least that's the theory behind it. And another big idea is the idea of a seam. If you look at the code as a large sheet, sometimes just, you could say, paper sheets with all the code printed out on it. You just need to look for ways where you can take this piece and put something else in between, like make it stuck there. And this could influence the behavior of the original code without touching it, but maybe by wrapping it or by injecting something else into it. So that's a very interesting idea I just wanted to mention. Another approach also from the title slide is to look for the churn monster. This is him. It's not very pretty. Churn is something, you could say it's change rate. So what you have to do is, and this is explained by Feathers as well as by Adam Thornhill, by Sandy Metz as well, in an interesting blog post with lots of nice little diagrams and examples from libraries. What you do is you take all of the files in your project and you run some analysis on it. So first you take a look at how many times has this file changed? How many commits basically are there that have a change in this file? So you use this information to put a dot on the horizontal line, right? And then for every file you find in your project, you also calculate complexity. Different ways to do that. You could just calculate cyclomatic complexity, or you could say, I'm just counting the lines of code, because that's usually already quite a good metric. So how many lines are in this file? And when combined, you can see what happens. So many files should be in the lower left corner, but there will be some exceptions there. And those will be your monsters, right? So there is this line that you can take. Like if it's below the line, it's okay. If it's to the top right of it, yeah, there may be some issues there, because these are like to the let's start with to the bottom, right? These are files that aren't very often changed, but they are also not very complex. So we can leave those alone. These are simple, small files, right, or classes if you like. Then to the top left, there will be very complex files, but nobody ever changes them. So yeah, it could be maybe generated code. Nobody cares about it. Because yeah, as soon as we have to change this complex code, things are going to be not very comfortable. Then there are files that change very often, but have a very low complexity. Those can be found to the bottom right, basically. And these are also very harmless, right? It may be something like a flip or something that we need to set somewhere, but there's no complexity there. But to the top right, files will be complex, like lots of lines of code, lots of complexity maybe inside the code, and they have to be changed a lot, or they have historically been changed a lot. So these are the issue where they will slow you down when you're working on it, and you will be very afraid of touching these files, right? It turns out that, and maybe this is something that, I mean, your project is currently on your mind maybe, and you know where the monsters are, probably. It turns out that many classes or files related, or that are these churn monsters, are related to core domain concepts. So very central concepts that are in the domain of your application. How could this be explained? Well, I don't fully know. I think it makes sense because in the domain there is knowledge, and you gain knowledge as developers, as a team. So it's only to be expected that things are changing in this area, right? So you try to reflect your domain knowledge in this code. And another part is that these are core concepts, so lots of the code you write for your application is going to be related to these core concepts, which means that if you work on a new feature that is also still related to a core concept, you start piling things up into these files. You're like, okay, so this is related to something I already know. Yeah, you open up the file, add some methods, maybe sometimes even subclass the existing class, I don't know, whatever you're allowed to do in your team. But yeah, so it's piling up and it's going to be a huge mess. So who knows the monsters in their project just by thinking about what could be large files that are often modified that we don't dare to touch anymore. Do you have any ideas? Yeah, oh, that's great. Yeah, so there is tooling for this. You can run it when you're back in the office, if you like. And I mean, it's a very simple metric to calculate. And it could be a good hint to start working there in the area where it's hard to change something, but where you nevertheless still have to change very often. Because it will make life a lot easier when you start improving the situation there. But you know, it's going to be a lot of work. And when I first created this talk, I was looking at our monster in this project. We had this 10,000 line class. Yeah, I mean, okay. This is the kind of thing that is that invokes a table flip as well as sadness, right? So it's a combined thing. In particular, because this is the place where there is no test, right? I mean, there are many places in the project where there are no tests, but this one in particular. And the funny thing is, I was happy to do this talk again, because now I can tell you that we have actually been improving the situation with this monster. And it turned out that this 10,000 line class was actually, it was related to sales, even though there was sales orders and sales invoices in there. And this is significant because the class was called sales. So it seemed like this was a case of, oh, this is probably related to this same core concept, so let's put it over here. So that's one part, and in fact, it turned out we could easily split this functionality like over different classes for sales orders and sales invoices. But there was also a case of like one single method, which was updating the order status after something had been invoiced. And this method was changed maybe 20 times. So this was a big issue where probably some new knowledge was acquired, some bugs were fixed over time. So this was a dangerous method, something hard to work with. And another one, which was all about dry. And maybe, as you know, the fear for duplicating code is a big reason why this kind of monster starts to come to life, because we feel like, oh, this method is already there, but it does sort of what I want already, so let's reuse this method by adding another method and calling that method, right? And this was the case in creating invoices, which was done in many different ways, but they all ended up being or calling the same methods in somewhere in the middle. So yeah, again, this was a matter of taking things apart, and now we have about, I think, 12 classes which are more or less standalone, which is a great situation for future rework. And in fact, I've been able to convince management as well that this is something we need to do, because we want to be able to look the monster in the eye from now on. And in fact, it shouldn't be a monster, it should just be like a teddy bear or something. We should be friends with it. So without tests, I think that's like refactoring by definition is changing the structure of your code without changing the behavior. And Martin Fowler is very explicit about it. You have to have tests in order to do that. Well, I think the whole practice of refactoring is just only making safe changes to the structure of your code. So you could say, well, let's not have tests, or like, what if we don't have tests? Can we still do refactoring? And yes, I think you can. Because in theory, of course, in practice, sometimes things go wrong. But usually, a refactoring is just a safe manipulation. You move a method to a different class, you extract a whole new class. You know, this can be done in a safe way. Still, I would call it brutal refactoring because you have no safety net. So you just do it, you see what happens. But yeah, in our project, this worked well. And the only problems that occurred were maybe some mistakes that I made, or some types that were currently strictly enforced while they were previously dynamic. So yeah, and this really helps finding some of the issues that were in the code. But you know, in the end, there were no big issues, and still we have been able to squash the bug basically, or the sales god. All right, so what else should I do besides brutal refactoring? Like, we just have to have the courage to do that thing, but what else should we do? Well, I think you should walk around in your code base, because a lot of the fear for these monsters and the fear for legacy, like the fear of changing things because you might break things, it's because there is not too much light. And one type of light I already mentioned is testing. Like, you can shine light on the code by writing tests, but you can also just shine light on the code by walking around, taking a look, just pick things up, right? And take a look at it, but just like also put it back, right? Just do the little things, cleaning up little issues in the code. Maybe there are some things that your static analysis tools can warn you about. Like, this is an issue. Maybe there is some code formatting you can do. Yeah, you know, in most languages, code formatting should not impact behavior. I don't know, but you know this about your language, so that's fine. It's like weeding the ground. Maybe you also need to, like I mentioned, add comments. So if you read code and you try to understand things, and you suddenly realize something, like have a bit of an insight in the domain or in the original authors, then add a comment there, right? Just do that. And like I said, be sure to put things back where they were. Like, don't go overboard and try to improve everything at once. I think that's one of the issues as well. Like, you have to learn to deal with a bad situation, or basically ignore it, because you are there for something else. You just want to understand a bit of the logic there. You're not there to change the world and improve everything. So that's something that's very important to keep in mind. Yeah, you could call this looking the monster in the eyes. And usually, in my experience, just looking around in the code base, seeing the things for what they are, it's like looking under your bed with and shining a light under it. Like, you don't have to be afraid of the monsters there anymore. It turns out to be a shadow of something, or maybe like the teddy bear, teddy bear, teddy bear. Interesting. Just when you're looking around, I find a very nice question, or a test for what's going on in that code, is to ask yourself, could this go somewhere else? Because that's, if you want to improve the code or the design, it's always very helpful if you could take this part that is very ugly, very bad, and move it to another place. And I find with legacy, like really the bad situations is it's impossible to move a class even, because it's supposed to be in that particular space or place. So once you can do this kind of thing, sort of make it not so static to this particular place, or like allowing it to have a different kind of a naming scheme even, then you're in a much better situation. But this is already going farther than just picking things up and putting it back again. Well, I think what's besides wondering what can we know about the project, how to deal with this stuff, how should we act even. Another important question with legacy is, what may I hope? Because legacy is not just there because somebody wanted it to be like that. It's there because there is a history. And we should always wonder, how do we get here? Because as you know, if you don't change anything about the environment or the people who are working on the project, even a big rewrite will get you in the same trouble as was in the situation before. Yeah, this may remind you of Conway's law as well. Like we will produce the software that sort of matches our organizational communication even, or the way we collaborate. So yeah, how do we get here? And how do we make sure that we don't end up in the same situation once we tackle all of this, once we improve the situation? Or try to improve, right? There will be developers, the changing team, changing landscape. Sometimes there is bad management. Some people will say any management is bad management. I don't know. Developers, bad developers. I think bad developers is just like bad managers. It's a bit of an issue because it has always to do with not knowing everything you should know to make the right decisions, right? So it's like developers aren't bad. They just don't know certain things yet, or have to be shown certain ways. So yeah, this is more like, okay, you could talk about it like this, but not really the right way of looking at things. I think mainly the issue is that people often don't realize, and also like many of the stakeholders don't realize, that once you have created a project, a software project, you need to keep take care of it. You can't just leave it there, like the final commit, push it to GitHub and be done with it, because if you wait for a year and don't look at it in between, then yeah, the project will have become outdated in lots of subtle ways, mainly because the world around it has changed, and not just because there are better alternatives today, but we maybe can't even upgrade anymore because some package mirror is offline that we were relying on, or the framework has security issues that should be patched, but we can't upgrade anymore because, well, we are relying on it in some way that is very fragile. So this is something everybody has to know about software development, including developers, but including everyone, every kind of stakeholder in the project. They should know that you have to take care of a project and basically never leave it alone unless you are okay with the idea that it's going to die in well, maybe 2 years or something. No, it's that moment will be quicker than you think. So you know what to do. I think just by going to a conference like this, you maybe already feel like, okay, thanks, yeah. So you have to write your tests and add some documentation, make all of your decisions explicit, work together in a sort of a coherent coding style and a standard, and well, we're on all the tools, etc. But yeah, I think you should make it so that your organization or your team can transform this hope into something like we can be certain of that. You can hope that people will do this, but it turns out that if you just hope that it's not going to happen, right? So I'm always looking for ways to maybe not force people, but to enforce, right? To make sure that you can't even do the wrong thing, like commit something where the tests would not pass, right? There are some issues with, like, what if someone doesn't even write tests at all? Like, how do you enforce that? You have to force them, but you don't have to force them. You just have to work together on it, and gradually the situation will improve, definitely. And that there's this thing where maybe you know how to do things, and instead of like using your power to do that, you should just sit together, like work on that together. So that's one way you can improve the situation. But then there is another way, and that is by not improving at all. Like, I mean, for the current behavior, you can do anything you want to improve. But for the legacy code, I think most of the deal is that you should realize that you don't have to improve everything. And this can sometimes be like the Atlas carrying the heavens, making sure it doesn't crash down. You should realize that most of the code in your project doesn't even have to be touched, doesn't have to be improved at all, can just remain untouched. I think in my current project, it's like half of it we don't care about even. It works, people are using it, happy about it, maybe some issues, and you can go in. But we don't even need to do brutal refactoring there. We can just make little changes if the user needs that. But we should also leave it alone. There's no reason to go in there. Where there is a reason to go in is where you find a tool or a new way of doing things, like dealing with email sending or translations, maybe, or dealing with time in your application. You will have to consolidate. This is my favorite word, also in tickets. I'm like, okay, let's consolidate the way we do this, right? And we have to go look in the code base and find every place where we do things related to, let's say, translations. And we should make sure that we have one way of doing it, so we can always have also this single point where we can change the way it works, instead of going all over the code base and tackling this. But at the same time, not everything needs consolidation. Or you could say not everything needs to be consistent. And as a legacy developer, you should really learn to make a distinction there. Like, could we live with this area of the code being designed very well and this other area not so well, right? As long as it doesn't get in the way of us producing useful things, perfectly fine, I think. So that's one thing where if you look for an architectural style, or you want to settle on a style, also make sure that it doesn't force you to have the whole project redesigned, right? Just make sure you can have this particular area where you can apply this proper design. All right. So one more thing that I think we may hope, but you play an important role in that, is that once you produce something, and even if you work towards a deadline, and maybe even take some shortcuts there, which is only the natural thing to do, I think, just make sure that everybody knows about what you're doing. You're growing software. And it keeps growing, but it also has to be nurtured for a long time. And just whenever you talk with any of the stakeholders, make sure that they are aware of this kind of thing. It's maybe this idea of having a prototype for an application, and you start working on a sort of a demo, and then you go back to your stakeholders and you say, yeah, it's going to cost X thousand dollars or something. And it's like, why? Because it already works, right? You have the prototype, you just release that one. And then you have to explain, okay, yeah, I understand why you would think that, but it's completely unmaintainable. It's going to be legacy code from today onwards. So yeah, this is you. You have to talk about that, explain what goes into software development and how you can keep the project alive for a long time. Because you are going to the conferences, you are reading the books, and you know how to do that. So, but now it's time to also get the money and the managers into this idea. Maybe that's very naive, right? Hope. It's almost by definition naive, unless you have some reason to assume that things are going to change, right? And maybe things aren't going to change. I have this sort of test for judging my own situations. I like to say this is it, or like to think this is it, or actually assume this is it. Because you can maybe change sort of your own behaviors or do something about something, but you usually can't change others or even environmental aspects or like maybe even the office place where you're working. There's nothing you can do about that. So this can be a good test, like assume that this is it. Nothing is ever going to change. How would you deal with that? Would it still be okay? Or are you actually still thinking like, okay, if only this would change, or I'm sure one day this person will start behaving differently, or they will understand one day. Assume that all of that won't happen. Could you still be happy working on this project? I think it's a good test to repeat for yourself every now and then. And then go back to yourself. Like there will always be something you can do to make the situation better. Even though you feel like you're just part of a bigger team, you're just a developer or something, you will definitely have some impact just by doing something and not even talking about it to others. I find that you will have this influence. You will make a change. You will maybe be the first one in your team to start writing a test, right? And that is something you do. You don't even say to others, you have to start writing tests or something, or you don't even do meetups about it or send memos about it. You just do it, and then suddenly someone else is interested in that. They want to learn how it works because they also like the green light when the test passes, right? They are also starting to look for 100% coverage. So this is the kind of thing where just by doing something yourself, you can definitely improve the situation and make a change. Just make sure that you will always look out for burnout, right? And there are different ways of looking at that. It can be that working with the legacy code is really just too much. And I experience this often where I'm just looking at the code and I just don't see it anymore. I'm trying to find out a way out of it, like get a better solution or something. And sometimes it turns out there is no better solution. So yeah, I should just let go of that idea, which is itself very hard because somehow I'm very optimistic and there should always be an answer or a better version of reality than this one. But sometimes there isn't, in particular in very shady areas of the domain. In fact, my colleagues know about this and they warn me about it. As I mentioned, working from home, it's sometimes hard to step away from the desk and realize that I can't do this, I can't carry this, I have to put this down and move on to something else. So it's always good to have the colleagues for that, and for everything else. Yeah, this is it. Both as a test for your life, as well as a test for this presentation. Thank you. All right. There's 5 minutes. Anyone wants to ask a question or say something? Mm-hmm. Okay. Yeah.
How would you approach refactoring in a group? Well, I mean, in a team setting, I know you work from home, but I work at a refactoring right now, and it's like changed 5 different labs. Other people are doing stuff now.
Mm-hmm.
What is the better approach?
Okay, so refactoring when other people are also working on the same code. Yeah, I think the best approach there is to do it together. In that case, first find a way to, like, if you have to work on it alone, that could certainly be the case. Then you first have to find a way to divide the code in such a way that you can, from that moment on, touch this code on your own without getting into the way of the others. There are different techniques for that. Just find a way to change the ownership there for the moment. Yeah. Okay. Mm-hmm. No questions? Okay, I think it's time for the break then. Thank you.